Hey guys, we are going to look at finding an inverse and answering a series of questions about this inverse. So what we're looking at is in your notes packet, the fifth page, the bottom two examples, right? The first example of these, there's two at the top. I'm going to show you those answers in a minute, but we're going to start with this third one down the page. And what they're asking you to do is to find the inverse and then actually answer this series of 6 things about it and to graph them, right? So first thing I did actually was, we know this is a parabola, but they're telling me here at the end that they only want to use x's greater than -3. So it's just this part of that parabola. And as you can tell, I've got multiple points plotted there along the way because we know how to plot a parabola. And I went ahead and I answered the domain because it's going to go from -3 to infinity. Notice it has a parentheses because they said everything greater than -3. They don't want to include the -3. You also could have said that this was x is greater than or equal, not equal to, is greater than -3. And for the range, same thing. You're not going to include that 1 point. So that could say that y is greater than 1 if you would like. Right? The top question it asks, that really does say, is it 1 to 1? That's how we read that. And 1 to 1, simply put, means that the inverse of whatever we're talking about will also be a function. We're not talking about the original expression itself. We're saying that the inverse of whatever we're looking at will actually also be a function. So the way that you check for that, that's what that HLT, horizontal line test, functions just like a vertical line test, but literally you hold the line horizontally. So again, we're just looking at this part right now, and that's what we would pass it across. And yep, it passes because I only touch the horizontal line to the graph one time. What that tells me, if you get yes, it's 1 to 1, that answers your function question over here. Is the inverse actually a function? Yes. And this is talking about the inverse, this whole side over here, right? So then the next thing I did was I found my inverse by actually swapping out the x and the y. F of x, which is my y, became the x, and my x here became the y. I subtracted 1. I took the square root. When I took the square root, because I introduced that square root, I have to do a piecewise. The nice thing here is, though, the piecewise is based on the y values, because that's what we're taking the square root of. And that said the y had to be greater than 3, -3. Or then you use the opposite piece if the y is less than -3. So because we originally set our domain for the original function at x is greater than -3, that means he switches and becomes my range. So my range, my y values of what we're talking about here, have to be greater than -3. So I'm only doing the top piece because that's the part where y is greater than -3. So I only have to do the y plus 3, not the -y minus 3 also. So I only get one part here, and that is a square root function. It's going to go right 1 and down 3. That's where I got this graph. And it doesn't have a vertical stretch or compression. So we simply follow the parent function then. Over 1, up 1, over 4, up 2, and you can actually fit over 9, up 3 on there. So my inverse function right here is what I've graphed here on the bottom. And we already knew that its domain had to be the range from over here, and that its range had to be the domain from the original. But you can look at this piece and you can tell that the domain is indeed everything bigger than 1, and the range is indeed everything bigger than -3. And if you recall from the last video, we talked about how these two pieces should be reflections across this y equals x line. Right? The bottom one, if we just kind of run through, that is going to be a root function, and it will 1, 2, 3, 4 look something like this. And we could actually graph more, but we'll just go with that. We know that his domain starts at -9, goes to infinity. We know that his range starts at 0 and goes to infinity. And if you look at it, would it pass a vertical line test? Yes, it should. And I called it a vertical line test. Sorry, a horizontal line test. Would it pass the horizontal line test? Passes horizontal line test. I would go ahead then, because this passes, and say yes, its inverse is a function. I also would go ahead and say, well, I know my domain has to be from 0 to infinity, and I know my range has to be -9 to infinity. And as far as calculating, then I could replace the f of x, which is the y, with my new x, replace the x with my y, and +9 stays. So I have to get rid of the root first. First thing I'm going to do is square that. So that will be x squared equals y plus 9. And then I will have to subtract the 9. So I get x squared minus 9 is my inverse. But I do have a restriction on my domain, or actually in this case, yeah, domain. The restriction is the range from before, so I only graph the right hand side, the part where x is 0 or larger. I know from looking at the parabola that this is a translation down 9 units, no stretch or compression. So over 2 up 4, over 3 up 9, 3 squared 9, 4 would be up 16, and so forth. And you could connect your points there. Oops, it should not tilt back in though, because it's a function. It's going to look something like that. And if we draw that y equals x line, it would actually go right through there. And if I'd drawn those a little more carefully, my intersection should have fallen on the y equals x line. Okay, if you'll flip the page, we're going to take a look. Oh, sorry. Actually, here's the top two. If you want to stop the video and try those two, check your answers. Here are the answers to those. Move that up a little bit. Alright, so there's the top two. Once you try those, go ahead and flip the page, and we're going to look at that graph at the bottom. Alright, I should have used a different color because that purple looks like black on here, but the original is the one going up and down, the A, the B, C, D, and so forth. It starts here on the right. And if you're going to graph, you literally just take the x and y points and switch them. So I simply took 3, -1, and made it be -1, 3. That became my A prime point. So -1, 3 is up here at A. Once I plotted B, I went ahead and started connecting just to make it a little bit easier. You take a minute, see if you can get these to connect and to look okay. And then the last thing we're going to do is we're going to look at a table, and on this table we want to, like we were doing it before, but instead of just adding two functions or doing a composition, we're going to do an inverse from this table. And so we might say, what is the inverse of f at 3? Well, this says what x value gives you an f value of 3. That's what we're asking. What x value, so your output, your answer, is going to be one of these numbers along the top, an x value. Which one of those lines up with an f value of 3? Well, when f is 3, the x that gets you there is 6. So this output would be 6. Right? You might have, what is g inverse of 5? Right? G inverse of 5 is not starting up here. That's not what they want me to do. They want me to go to the G, read along the bottom looking for 5, and it's the x value, so this would be a 4. That is different than if we say, what's g of 5? G of 5, this is your x value. So we go when x is 5 and we read that. Do you see the difference between the two? This one's an inverse. That little -1 up there tells you a whole lot. So please be careful. You're going to have both mixed up in the future.